We've now seen how HTTP lets us format our requests and responses to send information between the client and the server. In this video, I want to connect all of this knowledge back to what we've learned about endpoints. We're going to introduce this concept called REST, which gives us a set of rules when we're designing our endpoints to try to make them easier to use and easier to change. We're going to look at the design constraints, the rules of REST, and then take a minute to see how we actually implement RESTful endpoints in Express. So with that said, let us begin. So REST stands for Representational State Transfer. It's one of those acronyms that isn't really an acronym, but what this thing is a pattern for us when we are thinking about how to organize all of our endpoints and all of our communication between the server and the client. The goal of REST is to try to make our APIs a little bit closer adhering to a template. The idea is that if we design following the rules of REST, the APIs that we end up with are easier to maintain. If I make a change on the server, it's much less likely that I have to completely rewrite the client or vice versa. And in addition, RESTful APIs are really easy to scale. Even services like Facebook and Google are able to use these endpoints designed under RESTful principles in service of millions of users all at once. Just the way RESTful APIs work out makes them a natural fit for things like caching, things like content distribution networks. So when people are discussing REST, there's often a lot of debate about what REST is and isn't. There are entire books written about this. We are going to look at just a little bit the very general overview of the rules of RESTful design, but the way that these rules are broken down is into a series of constraints, rules that you have to follow when you're deciding how to break up your endpoints. So our first design principle of REST is the rule of uniformity. So the idea behind the rule of uniformity is that every endpoint in REST should be describing some action that happens to some resource. In the language of HTTP, this is sort of like how every endpoint has a verb and it has a path. And in REST, our paths are going to refer to nouns, things that exist. When you're deciding what nouns should be your endpoints, in REST, we try to make these representations as use independent as possible. We try to say it doesn't matter what the client is going to be doing. I'm just going to make things that are generally useful. And one of the neat little additions here is that in a RESTful API, there's supposed to be some notion of negotiation between the client and the server, where the client can state what it prefers, the server can state what it's willing to give back, and there can be some meat in the middle. In HTTP, this is done through the content type and accepts headers, where both sides are allowed to say what the other side is allowed to bring back and what it is that they're offering. This means that the same endpoint might be able to serve a web page or JSON or an XML document depending on the use that the client making the request has in mind. One of the other big features of the rule of uniformity is when you've got a resource, say one that you've retrieved with a GET request, the client should have all of the information it needs to be able to make a change or make a new resource, that the structure of these resources should be fairly static between all the different actions using that resource. In addition, these resources should have some knowledge of what else is out there. Say I am making my application and I've got a grocery store resource that gives back a name of fruit and a price and what department it's in. Under REST, I might choose to make that department a link to another endpoint. Maybe I've got a department resource as well. And so rather than just giving back the name, I might give back http mywebsite.com/API/departments/grocery. And because I've included that whole URL, someone using my API can sort of discover what else is out there just by using it. They don't need to go and refer to documentation. And that's really powerful. One, because it means there's less work for us. We don't have to document things. But two, because it empowers your users. Even if you make changes to things, they automatically get back what they need to use the rest of the API. However, the rule of uniformity is mostly this idea that the structure of our endpoints should be fairly standardized, and it should be based around actions happening to things that aren't just specifically what one particular client needs. So our next principle of REST is the principle of statelessness. In some other contexts, you might have heard of this same concept described as something like atomicity. The idea of the statelessness principle is when someone makes a request, that should represent a complete action from start to finish. Whatever they were doing before doesn't matter. Whatever they're doing afterward doesn't matter. And as a consequence, this means that the server doesn't need to store any temporary information. There's nothing like my endpoint step 3 of receiving wizard, where you're receiving a shipment and they have to call step 1 endpoint and then step 2 and then step 3. And if they call them out of order, everything explodes. That's bad because it means if your server has 100 people, it needs to keep track of those 100 different wizards that they're all doing right now. And that makes your server slower. It makes it so if you have multiple servers, someone has to keep interacting with the same single one. And it just generally complicates all of your code. Instead, in REST, your client is responsible for building this entire idea, and every single request that they make should have all of the information required to satisfy it. And the server can just take a quick glance at it, say, yes, this is a valid request you're making, or no, you can't do that, and then just respond and it's done. We can close off that connection right there. So I will point out, this is one area where people making REST APIs often cheat just a little bit. Technically, when you log in, you are now creating a session and you have to log in before you do anything else. That's state, and that's against the principles of REST. There are pretty sophisticated session management strategies that avoid the server having to keep track of state, but most often people cheat here, and the one little bit of state that they keep is there might be some database table that tracks who's logged in and for how long, and what cookie will let you know whether or not you're logged in. But in general, with a RESTful API, we want every request to be its own complete action on its own, so that once the response is given, the server can forget about it. Our next design principle is client-server separation. So the idea of client-server separation is that the client shouldn't really know anything about what the server's doing. Likewise, the server shouldn't really know anything about what the client's doing. And each of these should be able to evolve independently without modifying how they talk to one another. Obviously, there are limits to this. If your server now has an idea of this whole new thing that it never did before, Obviously, the client will need changes to know about that new thing. But the idea is, under REST, if you've designed a proper RESTful API, you might decide to change what database you're using. You might decide to change the tables. But the resources that you're exposing are things that generally make sense. And even if you've changed how you're storing the information, those resources can still exist independent of what's going on in the server or the client. This is one piece of REST that people often get wrong. I see a lot of RESTful endpoints that are just the name of a database table, and you get on that database table, you post on that database table to add rows or fetch rows. And that's not necessarily incorrect, but it is a oversimplification of what REST is supposed to be. In REST, resources do not have to correlate to your model objects in your code. In fact, two different RESTful resources can both be talking about the same data. Maybe the client doesn't know that when you get today's weather, you're actually also getting weather/date/month/year. Even if you have two resources that are the same on one end or the other, that doesn't necessarily have to inform what your endpoints look like. You should be designing endpoints that make sense for efficiently transmitting the information that you think has to get from one side to the other, no matter how it ends up bundled. So that is this idea that there should be a separation. As far as whose job is what, the client in a RESTful application is generally responsible for interpreting information. The client is the one that decides, what does this thing look like to a user? That's going to be our HTML and CSS using a little bit of browser JavaScript to assemble whatever it got back into something that makes sense. The client will also be responsible for making those requests. The user will click something, and that will indicate that the browser should launch off an action on a resource. Once that action makes it to the server's job in a RESTful API is just to do validating of a request saying, yes, you can do this. No, you can't do that. No, that doesn't even make sense. And then updating the model appropriately, either just fetching out information that was asked for or updating things, deleting things so that they conform to whatever was requested. And in a properly designed RESTful API, these are two separate components. It's almost like model view controller, if you've ever heard of that design paradigm, where the model exists as one set of code and the view, the things that the users interact with, is as isolated as possible. So those are the big rules of REST. There are a couple others that I am going to throw at you at once. And these are sort of the rules of scalability, I'm going to group them as. With REST, the idea is every response should have some notion of how long it's valid, what its lifetime is. And when you make that response, if the item is marked as valid for a certain period of time, the client should be okay with reusing that information so it doesn't have to request it every single time. Similarly, REST should support layering. What this means is that the client shouldn't necessarily know whether it's actually talking to the server or it's talking to an intermediary, something else that knows about whatever resource the client is requesting. This is useful for things like Cloudflare, if you've ever heard of that, or other content distribution networks, where you can pay someone to scale up your website, make it so you can service more requests at once. And a large part of the way that this works is by having those other services cache your resources. They'll fetch them and say, okay, I know that this is valid for X amount of time. And now they will handle all of the requests until it expires and they have to cache it again. That's not necessarily the most important priority if you are just designing your website for the first time, just learning how to write these RESTful APIs, but they are benefits that you get for free simply by creating something following the rules of REST. The last rule is one that pretty much everyone forgets about. It's one called code on demand, which is just saying that it's okay in a RESTful API to transmit logic along with a resource. A good example of this is if you're giving back an HTML page, it's okay for that HTML page to have some scripts attached to it that help you run things on the page. It's not the biggest deciding factor in how you design these sites, but it was a part of the dissertation, and so I'm including it for you. But these are the 6 rules of REST. And like I said, there have been entire books written about these. In terms of how this actually plays out, most of the time when we're talking about REST, we're talking about HTTP. And in HTTP, if we're implementing a RESTful API, our paths in our HTTP requests identify resources. And the verbs and status codes describe this control data about these resources, what action you want to perform and what action the server took in response. When we are supplying query string parameters or HTTP headers, we're able to do a little bit more negotiation to make sure our resources that we give back are in the correct format, are able to be interpreted by the client or server on the other side. And the important thing to note here is this is not the only way that REST can be implemented. These RESTful design ideas work in any protocol where you have a client and a server who are talking to each other. With that said, what I want to do now is look at how we can actually design endpoints in Express that follow these RESTful design principles. So I have a project here where I am going to make one of these RESTful APIs. My first step is going to be the first step I always have, which is I will need a main. And in that main, I'm going to go ahead and set myself up with Express. First, I'm going to install Express and body parser. And then once I've got Express and body parser, I will import them both. And then go ahead and create my app. We will even say this app. We already know we're going to be dealing with JSON, so let's get ourselves ready to parse that JSON. And then down at the bottom, give myself some port number and set the app up to listen on that port. Once it's ready, it'll tell us. And that's it. If we've done all that, we've got a web server spun up and ready to go. And for this example, I'm going to make myself a furniture store inventory system. So my other file is going to be furniture.js. Remember, when we have our Express app, normally it's a good idea to break that off. This part will be the same in almost every app. But over here, I'm going to create the code that just deals with this one resource here. So the first thing I'm going to do is try to describe for myself what this resource really looks like. And for me, I always do best with that when I describe it as a class. So a class is going to be all of the data that is part of one of these things. Maybe I decide every piece of furniture in my store has some ID, whatever's on the barcode when you check out. Maybe it's got a type like a chair or a table, a color, and a material. And then I decide I've got a constructor. I wouldn't be able to build one of these things if you give me a type and you give me a color and you give me a material. Then I can go ahead and set this thing up. This color is the color. This type is the type. And this material is the material. For ID, I'm going to be a little bit cheeky and I'm going to say ID will just count up. I will have some shared attribute next ID that starts at 1. And every time one of these pieces of furniture is created, the ID of that furniture is the current next ID. And then that next ID goes up by 1. It increments so that the next time I make one, it gets 2 and then 3 and then 4. I can even add other behaviors on here that might be useful in my program. I can do things like say, is this thing seating? It is seating if the type of thing is couch or the type of thing is recliner. I can add whatever functions I think are useful for one of these pieces of furniture. But now I've got this description of this resource from the server's perspective. However, that is different than the resources that we're creating in REST. To do that, remember, REST only exists at that communication barrier, which for us, using Express, is going to be in our router code. So I'm going to need to import a router and now set up a router to create the different actions that someone can do using this resource. So I've got my furniture routes, which is this new router. And this is what's ultimately going to be coming back from this file. I can actually say at the end, export this router so that I can go use it in my file. One last thing I'm going to do for myself, I am actually going to give myself some experimental data. In a real app, this database might not be an array that we create right here. It might be something that comes from a file. It might be something that connects directly to a real database with SQL. But for us today, I'm going to say, I've got a couple things here. Maybe there's a couch that's made of brown leather. Maybe there is a piece of furniture, which is a table made of brown wood. Maybe I've got a piece of furniture that is a recliner that is a blue cotton chair. There we go. I've got myself some data, so we'll be able to see our endpoints in action. And at this point, we need to start thinking about what things actually make sense to happen to one of my resources, one of my pieces of furniture here. One of the simplest things that could happen is someone might ask to see what furniture is out there. So we have to think about our HTTP verbs and decide on my furniture routes, which action makes sense for seeing all of this. I'm going to go with get because we had said get doesn't change anything and it returns information. So that sounds right to me. And I'm going to make an endpoint get furniture. This is a resource name. It's a noun. And that is typically how our RESTful API endpoints will look. It'll always be some noun that represents this thing. When someone tries to get this resource, I need to, in the simplest form, just return all of that. My JSON response is everything in my database. So you ask me for the furniture, here it is. Here's all the furniture. And that's it. We now have a RESTful API. It's a very pared down one, but it follows all of the rules of having this concept and then describing this resource using some action that can happen to it. Typically, we want to go a little bit further than this. One of the very first things that most people think about is, well, I don't want all of them. There might be 400 things in there. Maybe I want to talk about one specific one. When we've got a situation like that, that's still a get. That's still us saying, I want to receive information and not change anything. And it's still related to our furniture endpoint. But now we're not talking about the concept of furniture. Our resource, the thing that we're trying to achieve, is really one specific piece of furniture. Let me see the information about that. So conventionally in REST, what we do for this is we use a wildcard in the URL. We say, well, the furniture with this ID number, that's just the one that I want to get back. And this is a good point about REST, is that your resources are allowed to have sub-resources that just give you a portion of them. This is almost like our query string parameters from last video, but the difference is that this version gets accessed slightly differently in Express. So if I want to get just one particular piece of furniture, and I've supplied it here in the URL itself, I'm going to get that out with the request object from Express, but this params dictionary on it. And this params dictionary has anything that starts with a colon and then has a name. All of those become keys in this thing. So I can go and grab params ID, and that will get me back whatever someone put here, which I'm going to hope is a number representing an ID. And now I can look in my database for a match. I can say furniture database, find me the piece of furniture where the piece's ID equals that given identifier. And there are sort of two possibilities now. Either that piece of furniture does exist, which is easy. If that match exists, if I got something, so it's not undefined, that means I did get something back, I can just send that thing back. But now we've got a second option. With furniture, we were just giving back everything, so the user always gets something. With my furniture ID endpoint, there's the possibility that I can't find it. In this case, the user did something wrong. The user asked me for a thing that's not there, and me as the server, my response needs to be that I cannot find that thing that you're looking for. If you remember from our discussion of HTTP, the server has a means to communicate this, and in REST, we like to use the semantics of the protocol we're communicating with. So we're going to leverage that. We are going to say, my response is a status code of 404. If I want to feel helpful, I can even send a message back. Maybe cannot find a piece of furniture with the ID identifier. Now we're actually saying, I can't service this request. It's a 404, and we'll send back that 404 when someone asks for an ID of furniture that does not exist. So we've written a bunch of code now Real quick, let's attach this. Remember, you can attach this by importing that router in this case from our other file, and then saying app use on our API that router. Now I want to see this in action. So I'm going to go ahead and bun my main.js, and it will tell me that port 1234 is already in use. So I have another previous version running. Let's go ahead, kill that, run it again. And now if I switch over to my browser, I should be able to request from that endpoint, go to HTTP localhost and ask it for its furniture. When I do that, I get back all of those pieces of furniture with all of their information right here in the response. And if I ask for a specific piece of furniture, like I just care about API furniture number 1, when I make that request, I get back just furniture 1. I can ask for furniture 2, furniture 3, but if I ask for one that doesn't exist, like furniture 345454345, it's going to give me that 404. And it's actually communicated here right in the semantics of HTTP what it is that's wrong with my request. So someone receiving this doesn't even need to read the body. They've got their information right there and it's easily parsable in any client. That's the benefit of REST APIs, is that it becomes just a little bit easier to work with this thing on either side. So what I want to do now is add one extra detail to our get. Often we want something that's sort of halfway between this get me a specific thing and get me anything. So instead of giving back everything, I'm going to let my user search. A common pattern in these resource collection endpoints here, like our /furniture, is we can add query string parameters to filter this collection. I might say, I want people to be able to offer me a color in that request query string. So remember, this is different than params. Params was stuff here. The query collection is stuff after a question mark. So it's stuff in the format of question mark, color equals blue, and type equals couch. Maybe I decide someone can search on color. Maybe they can also search on type. And when I am giving back my responses, rather than giving everything, I'm going to get some results from my furniture database, filter this thing out so that each piece of furniture is a match if the color wasn't supplied or the color is the piece's color. So they have to match or you didn't ask for it. And similarly, do the same thing for our type. Either someone didn't tell me what type they wanted, or the type that they gave me is the type of this piece of furniture. And what this is going to do here is go piece by piece through my furniture and look at each one. Because this is a one-line one, I'm not even going to put the brackets. And here it's going to filter out each one. We could do this with a for loop just as easily. Loop through and check this condition on each one of our pieces, add them to an array of results, and then that's going to be the list of things that I return back. And if we make this change, I have to kill and restart my server. This is another common stumbling block I see. If you change your server code, you need to rerun your server or you will not see those changes reflected in your endpoints. But now, if I switch back over, I can get furniture and I'll still get all of the furniture. But I can also say, well, I want furniture where the color is brown. And if I ask for furniture where the color is brown, I get just the two that match that. If I say the color is brown and in addition, the type is a table, then I just get the one that matches all of that. If I ask for something that doesn't even exist, say, oh, well, the type needs to be a recliner, I'll get back an empty collection. And that is perfectly fine for our collection endpoint here. I am saying here are the matches that you have. We could choose to put a 404 here, but if it works, why mess with it? But now we've got the ability to search, and we've written search in a way that is very, very generic. This same exact logic, this same pattern will work if we've got, instead of a piece of furniture, we've got rooms in a building, and you want to filter on what floor it's on and how many seats it's got. The function is going to look almost identical. You're going to change the name of a few things and that's it. If you've got a politician and you've got their chamber of Congress and their state, this is going to look almost the same. It's just a politician with those features and everything else stays the same. You're still filtering and getting back those results. That is one of the beautiful things about REST, is this pattern works for pretty much any type of problem, and it makes it very, very cookie cutter, almost boring to write your server code because it all flows naturally from the patterns that REST forces you into. So the last example that I want to look at is, what if we actually want to change or add a piece of furniture? Conventionally in REST, changes happen with put and additions happen with post. Both are fairly similar. So I'm going to do post as an example here. I'm going to say, in my furniture routes, I want to be able to create a brand new piece of furniture. I am the store owner, and when I receive a shipment, I want to add one of these to my database. So the type of thing, the resource I'm interacting with is furniture still, and the action I'm doing is a post. The special thing about post, remember, is that it will have a request body, which we're parsing out with body parser. So here on the server, my job is to validate that you're allowed to do this, that this is a good request, which for this request is going to take the form of checking, have you given me a color for this piece of furniture? And have you given me a type for this piece of furniture? So are both of those defined? Is the material defined? Is this thing in a state where I feel comfortable adding it to my database? If you've given me all of those pieces, then I have everything I need to build one of these. So I can go ahead and make that new piece of furniture with that request body type and that request body color and that request body material. And once I've created this thing, I can throw it on my database, say furniture database, push that new piece of furniture into the collection. Maybe if we had a real SQL database, you'd be writing a query here. But then I'm ready to respond. I added the thing, and there actually is a status code for when something's created. It's 201. The 2 says it was successful. The 1 says something new was made. Maybe I even want to send this thing back so someone knows what ID it ended up with. You could even just send the ID here if you wanted. But now I've created an endpoint that when someone wants to create furniture, They send it to me, I validate it, and then I add it onto my database. In REST, I also have to consider what happens when they fail, when I'm rejecting this request. So I'm going to put an else here. And if they're missing a property, if one of these things wasn't supplied, then that's not my fault. So I am going to use status code as I have been to communicate what's going on. And it has to be in a 400 class. I'm going to say status 400, and I will send back unable to create furniture, missing one of color, type, or material. I've now given a helpful little message to my user saying, this is why I am not fulfilling your request. It was a bad request. It was missing one of these properties. In this way, our API is almost self-documenting. When someone tries to use the thing, they can just experiment with it and they will get back codes that work the same as every other RESTful API on the internet. So they're really intuitive to understand, especially if we include helpful error messages like this. So to see this in action one last time, I'm going to restart my server, swap back over to my browser, and now our gets still work. I can still get my 3 pieces of furniture that are available now. But if I switch over to post and I set the content type of this post to be application JSON in the body, then in here I can say, well, I want to make a blue, we'll say the type is couch and the material is, I don't know, suede. I've defined my new resource here. And when I send this, I get back my 201 created. I see here's the thing that was created. And if I go and I get from this endpoint, I now see 4 things in here. This couch that we just created was added. We've got our pair to our recliner up above. And one of the neat things is, if I am someone and I am just learning this API for the first time, I can sort of get a model to work from by getting a piece of furniture. This here has everything I need to also be able to post. I can start from that and say, well, I'm going to try and just experiment and make one of these things in the same format. I'm going to try to make a table that is green made of glass. And I'm not playing with the structure. The structure is exactly the same as I was given. And if I post to this endpoint, it's actually going to complain here because I am missing a because I didn't set the header. The content type to application JSON. Go ahead and submit it. And then it will be able to process the request. I do think it may have crashed my server when I did not send it as the correct format. But that is a great example of how this API becomes discoverable. By using a consistent interface for our post and our get, we're able to make it easier for someone learning our API to be able to use it. So we've now looked at creating a RESTful API that includes creating resource collection getters, individual item getters, and posts. And a put would be the exact same way. You would just put to an existing thing at an ID, sort of combining our features of our ID getter and our poster here. But this gives you a great first look at a way to design APIs that works for any type of problem you might have. Once we know that, writing our clients is going to become much, much simpler. So I look forward to showing you all that in the next one.